Hello, I'm Beck. I'm a cybersecurity engineer at MITRE, and I'll be talking about the Malware Behavior Catalog, otherwise known as MBC, which provides a standardized vocabulary to support malware analysis use cases. I'll be focusing on using MBC for standardized reporting, which improves interpretation of malware analysis results, as well as how those results can be used for detection and mitigation. So I'll start with an overview of MBC to include other use cases, its relationship to MITRE ATT&CK and MBC's components. And then from there, we'll focus on how MBC is used in standardized reporting. So MBC is a catalog of objectives and behaviors created to support malware analysis use cases. So to get started, here's an example of some of the objectives, which are in the bolder font, and behaviors, which are in the regular font, that might be associated with the malware sample. So it could be, if you look under the anti-behavioral analysis, malware may make analysis difficult by delaying execution or having obfuscated code. It may disable security tools. Under impact, you'll see it may hijack system resources. And this is just a sampling of the behaviors that are defined in MBC that can be associated with the malware sample. So as far as other use cases, today we're going to focus on standardized reporting, but there are other use cases as well. So for example, MBC can be used to correlate malware analysis results. So say you have, different tools, a couple of different tools, you can, if they're both mapped into MBC, you can compare to see if the results agree. If they do agree, you could be more confident in the results. And if they don't agree, then you'll know where to focus for further analysis. MBC also supports malware labeling to generate data sets for research. So, given a data set which has its behaviors labeled with MBC would enable, researchers to extract whatever subset that meets some chosen criteria. And then also it supports, the malware analysis process. And that's because having a set of behaviors identified and organized helps an analyst know what to look for. So I'm sure many viewers are familiar with MITRE ATT&CK. It's a curated knowledge base and model for cyber adversary behavior, and it's widely used to capture various aspects of the adversary lifecycle. So I want to point out that MBC is not part of ATT&CK. The MBC team is not part of the ATT&CK team. They're independent efforts, but MBC is related to ATT&CK, so it's important to know the basics and to understand that relationship between them. Attack for Enterprise defines adversary TTP seen during the analysis of an intrusion, and the associated tactics, the adversary's technical goals, range from initial access to impact and are listed there underneath the Attack for Enterprise label. And they aren't shown, but associated with each tactic are what ATT&CK calls techniques, which are how an adversary achieves a tactical objective. And then you've got pre-attack, it covers the earlier phases of a cyber attack, but its tactics aren't shown because they don't relate to MBC. And a few years ago, we talked to the ATT&CK team, our MBC team, talked to them about expanding ATT&CK to cover malware analysis more thoroughly, or those use cases more thoroughly. But we weren't the only ones wanting ATT&CK to expand, and ATT&CK can't expand to cover every use case and everybody who wants it to. So instead, we decided to develop MBC, not just to support malware analysis, but also, as a model and a test case for how ATT&CK could be modified by second parties. So, as far as adversary behaviors and malware behaviors, they overlap. Adversaries sometimes use malware. MBC aside, ATT&CK is used in reporting to capture malware behaviors. So, for example, Joe Sandbox, Falcon Sandbox, AnyRun, Cuckoo Sandbox, they currently map behaviors to attack techniques. But ATT&CK is oriented toward adversaries, not malware. It generally focuses on behaviors identified during an intrusion, rather than those discovered during analyses like are done for malware. And that's not to say some malware behaviors don't map nicely into ATT&CK. Many do. For example, you'll see that example there, starts command.exe for commands execution. That maps to attack version 7, its subtechnique, command and scripting interpreter, Windows command shell. But there are some malware behaviors that can't be mapped. The best examples are anti-analysis behaviors, like those that are listed, for example, queries, kernel, debugger information. So those missing behaviors in attack motivated the development for MBC. So MBC expands upon attack by defining new behaviors, like anti-analysis behaviors and what we call micro-behaviors, which I'll define in a minute. MBC moves away from attack's focus on the adversary perspective and instead focuses on malware code. And as the diagram there, the table shows, MBC version 2, it's been updated to work or to be compatible with attack version 7. It defines 41 new behaviors, 23 micro behaviors, and it enhances with malware analysis details 30 attack techniques or sub-techniques. And if you're familiar with the philosophy of the attack methodology, you'll recognize the bullets in blue as malware code-oriented analogs. So MBC maintains a malware code-oriented perspective. It focuses on real-world malware behaviors, and it maintains an appropriate level of abstraction. So these are the components of MBC. We've got the objectives, which are, those are why malware does something. A behavior or micro-behavior captures what the malware does to accomplish the objective, and a method refines the behavior. So the standard way of capturing the components is as a list separated with double colons, where the objective is in all caps, and that's our convention for using MBC. And then these three components have equivalence in attack. Objectives are like tactics, behaviors are like techniques. MBC defined methods before attack defined sub-techniques, so they're a bit different, but they serve a similar purpose. And in MBC, we're also building a collection of malware that exhibit the different behaviors and methods. And we haven't done it yet, but we're planning to build a library of code snippets that exemplify each behavior. So MBC adopts attack's higher level structure, and many MBC objectives correspond to attack tactics. The objectives are shown on this slide, and if you're familiar with attack, you'll recognize persistence, execution, impact, and so forth. Then the objectives outlined in yellow are not defined in attack, but they're key to malware analysis, such as the anti-analysis objectives up in the upper right. And we also found, when we looked at behaviors identified by analysis tools, some that were really low level. They supported many objectives and other behaviors. They weren't malicious in and of themselves, but they're often identified during analysis, so they're captured. So we capture them in MBC, and those are what we call micro behaviors, and then the associated micro objectives that are kind of like the categories of the micro behaviors, and they're related to things like HTTP, FTP, DNS communication, cryptography, and so forth. So as far as MBC relative to attack, they are meant to be used in combination, or MBC is meant to be used in combination with attack. We don't want to duplicate attack content. In MBC version 1, if you've seen it before, at that point we were referencing all attack techniques relevant to malware analysis. There was a stub for each individual technique that applied to malware. But in version 2, we've moved away from that. And version 2 of MBC only contains behaviors that are new or have added content. So with the idea that attack techniques will still be referenced and used as needed. So in some cases, though, we've enhanced an attack technique, and that's the malware behavior. It extends attack's description to cover some specific aspect of malware. In other cases, we found that an attack technique was too broad, so we refined it and defined multiple behaviors. And there's an example there of, software packing. An attack relates to both what we think of as packing from a malware perspective, as well as, of obfuscation of executable code. We've separated those, and there are two different behaviors in MBC. And then when there is no attack technique, for a behavior that's needed to support a malware analysis use case, we define a new MBC-only behavior. And it's been interesting because ATT&CK has grown over the years to include techniques that MBC had already defined. And so this example shows kind of how we handle those cases. So the attack technique, virtualization, sandbox evasion, which is associated with the defense evasion tactic, was defined after we defined related behaviors in MBC. MBC has these kind of lower level descriptions or definitions of behaviors. MBC separates detect from evade, and we separate sandboxes from virtual machines. But as the arrows show, some of the MBC methods relate to attack sub-techniques. I mean, they're the same, after when you look at their definitions. So to make things less confusing, we reference the attack content, as I'll show in the next slide. So here's an example. MBC is available as markdown files on GitHub. I'll give the link and more information at the end of the talk. And this is an example of one of the behavior pages. This is the dynamic analysis evasion behavior that I showed on the previous slide. And so you can see that at the top of the table that we show that the virtualization sandbox evasion attack technique is shown to be related. We list it there. And then if you see down into the description for one of the methods, the delayed execution method, it too includes a reference to the time-based evasion subtechnique that attack defines. So we do link it up so as to show what's equivalent or similarities between the two, between attack and MBC. So there wasn't room to show the entire page associated with this behavior, but each page also includes a table of example malware that exhibit the behavior, and then references and so forth. So with the basics of MBC covered, I'll now talk about how MBC is used in standardized reporting. Assuming STIX is used as the reporting format, there are 3 components. One component involves mapping tool signatures that will generate analysis content to MBC. And then the second component is that MBC must be expressed in STIX. And a third component is that the tool report, the output that the tool provides, that too must be translated into STIX. So those are the 3 pieces. And I'll be using Cuckoo Sandbox for the signature mapping example. So Cuckoo Sandbox has a community repository of 565 signatures. And of those, 313 are behaviors that are appropriate for mapping to MBC or attack. The others are AV related or not behavior related. And then 165 signatures were already mapped to attack version 6. Those were in the community repository, included those mappings. But then we used MBC's, malware focused content, and we were able to update 83 with a more accurate mapping. That actually means we changed the mapping to something that was more related in looking at the signatures. And then we extended 21 of them. Extension meaning that we defined an additional behavior. There are some signatures that have more than one behavior mapped to it. And then working with the MBC only behaviors that we define, we were able to look at some of the other signatures, and in the end we defined 148 new mappings. So we got a lot more coverage by having the malware focus of MBC. So this table shows a few example mappings. Some signatures map to MBC behaviors, which have identifiers starting with a B, that's in the first line there of the table. And then some map to micro behaviors. Their identifiers start with a C. And actually it was by working through the Cuckoo signatures that we decided to define micro behaviors in the first place, because there were a lot of things that weren't mapping, low-level things, and that's where the idea came from. And then some signatures map to attack techniques that have malware-focused enhanced content. And those identifiers start with an E for enhanced, and they keep the same number as an attack, and that's the third line there, the process injection, process hollowing example. And then there are some signatures that map to standard attack techniques. those identifiers start with a T. And then given the mapping, so we mapped all the signatures that were in the repository. Given that, we then added the proper identifier to the Cuckoo signature. And so I've shown an example of the signature. This is the signature that goes along with the anti-sandbox sleep signature defined in Cuckoo. And you can see in the TTP field, we've added that which corresponds to the dynamic analysis evasion delayed execution. That's the B0003.003. So, and then the latest mapping, which includes, so it uses MBC version 2 and attack version 7. That's available on GitHub on the MBC project pages, so you can find it there. So we have the tool, in this case, Cuckoo, mapped to MBC and attack, as we just looked at. So now we need to express MBC and the Cuckoo output in STIX. So STIX is a language for exchanging cyber threat information. I don't have time to go into the details, but I've given the reference to the latest committee specification there at the bottom of the slide. For those who are familiar with STIX, the relevant SDOs are the attack pattern, malware analysis, and malware objects. And then we use the relationship objects to associate the actual MBC behaviors with analyses and malware samples. So I'll show a couple of examples next. So expressing MBC in STIX, that's what enables you to then use MBC through tooling and APIs. And we've used the same STIX objects as attack uses to express its content. So if you're already using attack, using MBC, it shouldn't be any different, because we're using, for example, each of our behaviors is captured as an attack pattern object. As you can see in this example, the name of the property is the name of the behavior. The phase name of a kill chain, also highlighted up there, corresponds to the objective or tactic, as attack would say. And then the identifier is defined as a property of an external reference. And the content is available. There's a MBC-STIX2 repository on GitHub, and I put the link there where you can get that content. And then these next two slides show how Cuckoo analysis results and MBC can be captured in STIX 2.1. So this analysis, malware analysis object, captures the Cuckoo output. You see that Cuckoo is listed as the product, and then the various analysis details are captured in different object properties. I haven't really gone into them here, but it may be found a domain name or IP addresses. You can see that those are there. Whatever is in that Cuckoo report would be captured in the malware analysis object. And then kind of the MBC related part to that is that there's the STIX relationship object is used. And so in this example, you can see that the object type is derived from, or the relationship type is derived from, with the source, the attack pattern, which corresponds to the behavior, and the target is the malware analysis object, which corresponds to the Cuckoo analysis. So this kind of reads, the behavior was derived from the analysis. And then a similar relationship could be used to associate the MBC behavior, or the malware behavior really, with the actual malware sample. So that's, again, you kind of have to have some knowledge of STIX to thoroughly understand this, but it kind of gives an idea of how, the standardized reporting comes out from using MBC. So as far as next steps, we'd like to define mappings between MBC and other analysis tools, like we've done for Cuckoo. We're currently mapping the FireEye Flare Team's open source Kappa tool to MBC, and hope to have that done relatively soon. We also plan to expand the malware example content and to create a repository of code snippets to provide examples of how each behavior is implemented. And then for now, all the content is in Markdown files on GitHub. The GitHub site has separate pages for each behavior. There's a fairly long list of FAQs and a set of malware examples, or example malware. A few organizations are using MBC, but it'd be great, of course, to have more people using it and helping to refine it. So please have a look at GitHub, and if you'd like to join the discussion list, please send a request to mbc@mitre.org. So thank you very much.